Much of New England is covered in hills, lakes, and mountains. But how did they get here? Today, we'll explore the geography of the area around us to learn why our world is how it is. To understand the formation of the land around us, we'll need to travel back 20,000 years to the peak of the last ice age. At this time, an enormous glacier called the Laurentide Ice Sheet covered most of the top third of North America. This ice sheet was also incredibly thick. Over Massachusetts, the glacier's surface could be more than a quarter mile above the ground. That's about 4.5 Statues of Liberty stacked on top of one another. As the Laurentide ice sheet advanced over North America, it picked up huge amounts of rocks and sediment by bulldozing hills and other terrain as it progressed. About 14,000 years ago, at the end of the Pleistocene epoch, the ice sheet began to retreat. As it retreated, this sediment was simply dumped onto the ground. At Drumlin Farm in Lincoln, we can find a hill composed of this sediment, a drumlin. The best way to identify a drumlin is its irregular shape. As the glacier melts, the enormous amount of water being released creates streams of meltwater flowing away from the glacier. These streams flow around the drumlin, making the side facing the glacier steeper, while simultaneously depositing sediment on the other side of the drumlin. This process creates an irregular shape with a steep side facing north, followed by a slow, gentler slope on the other side, as seen here and here. Another interesting feature of the drumlin is that it has several glacial erratics, large boulders dropped by the glacier, sitting on top as more evidence of glaciation. As the glacier retreated, its streams of meltwater flowed into valleys, forming enormous glacial lakes. Glacial Lakes Concord and Sudbury are the two nearest to us. Glacial Lake Concord is farther north and was at least 10 miles wide. This lake was fed by meltwater streams from the retreating Laurentide ice sheet. These streams were laden with sediment that the ice sheet had picked up, but as they entered the lake, the stream's speed and competency quickly decreased, and the stream dropped sediment at its mouth, creating a delta of well-sorted sediment. This delta, called the Kame Delta because it was formed from glacial sediment and meltwater, was raised above the rest of the lake floor and became Author's Ridge. Another interesting part of this delta is that since the meltwater streams were coming directly off of the glacier, one side of the delta was touching the ice. When the ice melted away, this left a steep face called an ice contact head on one side of the delta, shown in red. Also, because there is water involved in the creation of this Kame Delta, the sediment that made it up is well sorted. Here, we can see the sediment, where its fine, sandy size stands in stark contrast to the unsorted rocky tail that New England is known for. Another place where you can see cames is at Fairyland Pond in Concord. In this area, the cames weren't created with rivers of meltwater like on Author's Ridge. Instead, the water that sorted their sediment came from pools on top of the glacier. These pools gave the sediment lots of time in the still water to become well sorted or stratified. When the glacier fully melted, the stratified sediment was dumped onto the ground, forming cames. Now, let's talk about the pond itself. This specific pond is a kettle pond, meaning it was formed when a large sheet of ice broke off the retreating Laurentide ice sheet. Sediment dumped from the glacier around the same time, likely stratified like the came surrounding the pond, buried the chunk of ice. As the ice melted, the sediment originally on top sunk to the bottom, leaving behind a large hole, a kettle, filled with water from the melted ice block and fed by streams. Kettle lakes can be very deep. For example, Walden Pond, another kettle pond, is the deepest freshwater body in Massachusetts. Unlike Walden Pond, however, Fairyland Pond is only a few feet deep. At the Acton Arboretum in Acton, there are even more interesting glacial features. Taking the bog trail brings us across a small bog formed in a kettle hole, just like Fairyland and Walden Ponds. Similar to Fairyland Pond, this bog is very shallow, with wetland plants and foliage growing in all but the deepest parts. Farther down the bog trail exists another glacial feature, an esker. This long, noodle-shaped feature is about 10 feet tall and looks like a small ridge that extends north to south through the forest. Eskers are formed when a cave in a glacier fills with sediment and meltwater. The meltwater sorts the glacial sediment just like with caves, so when the glacier retreats, the line of well-sorted sediment in the shape of the cave is left behind, a fossil of the inside of the glacier. We've talked a lot about glaciers depositing things, but how did they get the rocks and sediment that they deposit? When a glacier moves through an area, it plows away the loose topsoil. It can also leave a variety of erosional features on the bedrock by scraping and cutting it away. One of these features, a U-shaped valley, occurs when a glacier moves down a valley and erodes away all sides of it, cutting it into a U shape. One of these valleys can be found with the Concord River flowing through it. Since rivers only create V-shaped valleys where the only erosion is downward, we can tell that the Concord River is using a valley created by a glacier, and therefore was formed during the retreat of the Laurentide ice sheet about 14,000 years ago. In the time since, the river has created many features, including a large floodplain, many wide meanders, point bars, and cut banks. The slow speed of the river suggests a low gradient supporting deposition. All of these features suggest that the Concord River is an old river, although the lack of meander cutoffs or oxbow lakes suggest that it is not extremely old.